Supplemental math videos from Circle Christian School.
Polygons and apothems. They have sides, they have angles. Some are regular with congruent sides and congruent angles. And then there is the apothem, the perpendicular bisector from the center of the polygon to the opposite side. See, everything really does go back to a right triangle. Okay, polygons. It's a multi-sided figure. A convex polygon does not have any openings to it, like this pentagon, while a concave polygon has some sort of entrance inside it, like this pentagon. Basically, if you can draw a line through the inside to the outside to the inside again, you have a convex polygon. These are the names of your basic polygons. Notice the suffix tells you pretty much how many sides there are. The measure for the sum of the angles in a polygon is the number of sides minus 2 times 180 degrees. On a regular polygon, one angle, since they're all congruent, would be the sum of all the angles times 180 degrees divided by the number of sides. That would give us one angle. Let's say that you have been given a polygon with the sum of the measures of all the angles together equals 1,980 degrees. How many sides? Yeah, let's try this. Many sides. So we're just going to use our formula here and replace some things. Well, the sum of all the angles is 1,980. And we're looking for the sides. So n will stay n equals 180 degrees. So I'm going to divide out the 180 degrees and divide out the 180 degrees, which means now we have n minus 2 equals 11. And then if we just add 2 to both sides here, we find we have a polygon with 13 sides. Now for the fun part, the apothem of a regular polygon. The apothem is the perpendicular bisector. That is a perpendicular line. Bisector means it cuts it in half. That is a perpendicular bisector from the center of the polygon that goes to the opposite side. All right, let's draw a picture of that. So I'm going to start with a pentagon. I could do a pentagon. Pentagon's all right. So I'm going to do a regular pentagon. And this is going to be a little bit rough, but it'll be darn close. There we go. And I want to find the apothem of the pentagon. So I have 5 congruent sides. And here's the center. Now what we're going to do is actually divide our pentagon up into equal triangles. Each one of these triangles is an isosceles triangle. That means their sides are congruent. Now another important formula in here is the measurement of the angles off the center. And that formula for the angles off the center is 360 degrees, because that's the circle going around in the center there, and we're going to divide it by the number of sides. So what we have here is 360 degrees divided by 5, which in this case is going to equal 72 degrees. So what we're going to do is take out one of these triangles here. So I'm going to redraw just one of the triangles.
Ms. Washington.
All right, I'm going to take out just one of these triangles. Put some of the things that I've been given. Isosceles. We know that the angle at the top equals 72 degrees. And I'm going to put in an apothem, the perpendicular bisector. I'm going to call it A for an apothem. So what we're going to do is actually go find how big that apothem is, which we can do by using our right triangle properties. So let's say our pentagon in the very beginning had sides that equaled 4. Each one of the sides were 4 units. That means this side of the triangle is 2, and this side of the triangle is also 2. So again, I'm going to take out another triangle, keep separating out these triangles, and we're going to go find our apothem. So we have 2 here. We have our perpendicular side. Here's our little apothem. And we have half of a top angle, which is 36 degrees. So everything really does go back to a right triangle. So we're going to start with a target. We're going to label, identify our H, our opposite, and our adjacent. And now we're going to find our apothem, which has these 2 values right here. So we have an O and an A, which means we're going to use tangent. Our target angle, 36 degrees, equals O over A, or 2 over the apothem. Since the variable is down in the denominator, I am going to divide by the trig, tan 36. And using our handy-dandy little calculator, we get, and we find our apothem equals approximately 2.75 units. So now we have just about everything that we need to go and solve this triangle. Things like we can find the area, which equals 1/2 the base times the height. We have our base here, which is 2. We have our height. Or if we wanted to do the whole triangle, it would be 4. So 1/2, 4 times our height, 2.75, which would be 2 times 2.75 for an area total of 0, 1, 15, 1, 5, 2 behind, an area of 5.50. And then if we wanted to find the area of the whole pentagon, we would take our answer and multiply it by 5 triangles. So we would have 5.5 times the 5 for an area of our cute little pentagon, 27.5 units strong. And that's what an apothem does. Otherwise, for the rest of the polygons that you'll be dealing with, you're generally just looking for a missing angle. So use the sum of the angles, or if it's a regular polygon, one angle down there to find out what's missing. Okay, have an awesome day.